Dear viewers, today's video I will try to discuss about binomial distribution. Firstly, I will try to define binomial distribution and then how to find out mean and variance of binomial distribution. So let's start. Uh, Binomial distribution is one kind of discrete distribution. Why it is discrete? Because from binomial distribution, x is countably finite number of values. X is countably finite number of values. For this reason, binomial distribution is one kind of discrete distribution. Binomial distribution has two types of fair outcome. Let's get an example. If a fair coin will toss two times, we get the result head or tail. And another example, children born in a community. Here the children will be boys or girls. So in such situation we have to apply binomial distribution. Now first I will try to define binomial distribution. Here the definition is: a discrete random variable x is said to have a binomial distribution if its probability function is defined by function of x n comma p equals to n combination x into p to the power x q to the power n minus x. Here for x equals to 0, 1, 2, 2n, and this result will become 0 otherwise. Here n and p are the two parameters. P satisfy the condition 0 is less than or equal p is less than or equal 1, n is integer number, and q is the probability of failure, and p plus q equals to 1. Now we will describe how to find out the mean of binomial distribution. So before find out the mean, I will inform you that binomial distribution follows some condition, such the result of one trial don't affect another, and the second condition will be conditions are same for each trial, and next here the trials are finite and constant. So now describe the mean. Here the mean is first moment about origin mu 1 prime equals to expectation of x. Expectation of x will be written as summation of x into f of x. Here summation of x equals to 0 to n x into what is the value of f of x? The value of f of x from binomial probability function we know n combination x p to the power x q to the power n minus x. The next line will become x equals to 1 to n. Why x equals to 1? Because if we put x equals to 0, the whole term will become 0. This way this summation will start from x equals to 1 to n. X into here the combination, here from combination n combination x will be written as this form. We know combinations formula NCR equals to n factorial by n minus r factorial into r factorial. This way we can write n combination x as n into n minus 1 factorial by here x factorial into here x factorial into n minus x factorial, n minus x factorial, and the remaining term p to the power x into here we keep a term p by p for more convenience our estimation, q to the power n minus x. Here the term n into n minus 1, from this way we know n factorial equals to n into n minus 1 factorial, like 4 factorial equals to 4 into 3 factorial. This way n factorial will become n into n minus 1 factorial, and then summation of x equals to 1 to n, here x into we can write n into n minus 1 factorial by x factorial will be written as this way: x into x minus 1 factorial into here the term n minus x factorial, and the remain term p to the power x p by p into q to the power n minus x. Now x and x will cancel out, and here the term n and here the term n and this p will keep outside of summation. N p will keep outside the summation, x equals to 1 to n, and here the remaining term will n minus 1 factorial by x minus 1 factorial into n minus x factorial into p to the power x. Here the term p to the power x minus, as the base is equal, so p to the power x minus 1 into q to the power n minus x. Now we have to assume the term x minus 1 equals to y. Let x minus 1 equals to y when we put x equals to 1, then we will get y equals to 0, and when we put x equals to n, then we get y equals to n minus 1, and the term x will 1 plus y. So from now we can write np summation of y equals to 0 to n minus 1 factorial by y factorial, because x minus 1 equals to y, y factorial into n minus 1 minus y factorial. N minus x, from n minus x will be written as n minus 1 minus y if we put the value of n and the value of n, and here p to the power y into q to the power n minus 1 minus y, and then np into summation of y equals to 0 to n minus 1, here n minus 1 n minus 1 we can write the term n minus 1 the term n minus 1 combination y into p to the power y into q to the power n minus 1 minus y. The term will be written as this form, and we have known that this form is to be converted into binomial form. If we convert it binomial form, then we will get p plus q to the power something, and if we put p plus q equals to 1, then we will able to find out the mean. So np, so summation of y equals to 0 to n minus 1. Here the term n minus 1 will be assumed t. Let n minus 1 equals to t, and we can write here t combination y, p to the power y into q to the power t minus y, the term t minus y. The whole term will become p plus q, because from binomial series we know that np into summation of y equals to 0 to n minus 1, the whole term will become p plus q. From binomial series we know that total probability equals to 1. Total probability p plus q equals to 1 to the power here t from binomial form. Equals to np into p plus q to the power, here put the t's value, t equals to n minus 1 equals to np into p plus q equals to 1 to the power n minus 1, that's mean 1, and finally we get the mean of binomial distribution equals to np is the mean. Now we will try to find out the variance of binomial distribution. From variance formula we have known that variance of x equals to expectation of x square minus expectation of x whole square. Now first we have to find out the value expectation of x square. So now expectation of x square will be written as expectation of x into x minus 1 plus x. Expectation of x square will be written as x into x minus 1 plus x for more convenience of our estimation, and then we divide this term expectation of x into x minus 1 plus expectation of x. Here we get the next term, the next line will become summation of x equals to 0 to n x into x minus 1 f of x plus expectation of x, we have known that the mean of binomial distribution, expectation of x whose value is equals to np, and then summation of x equals to 2 to n. Why x equals to 2? Because if we put x equals to 1, 0, 1, then the whole term will become 0. So the summation will start from x equals to 2 to n, and finally we get x into x minus 1 f of x. Now we put here the value of f of x, n, from binomial from n x p to the power x q to the power n minus x plus np. And then we can write here summation of x equals to 2 to n x into x minus 1. Now from combination formula we can write this term n into n minus 1 into n minus 2, because we have known that n factorial equals to n into n minus 1 factorial. This way we can write n factorial equals to n into n minus 1 n minus 2 factorial, and the denominator will be x into x minus 1 into x minus 2 factorial into n minus x factorial, and the remaining term p to the power x into here we put an extra term p square by p square for more convenience of our estimation, q to the power n minus x plus np. Now here the term x into x minus 1, here the term x into x minus 1, x cancel out, x minus 1 will be cancel out, and the remaining term is here. We can write n into n minus 1 and p square. N into n minus 1 and p square will put outside of the summation. Then we can write n into n minus 1 into p square summation of x equals to 2 to n, and the remaining term here n minus 2 factorial by the denominator will be x minus 2 factorial n minus x factorial p to the power, here base are equal, so power will be x minus 2 and q to the power n minus x plus np. So the next line will be n into n minus 1 p square. Now we have to do a simple task here. Here we assume that x minus 2 equals to r. Let r equals to x minus 2 and n minus 2 equals to m equals to n minus 2. So we get the value of n equals to, then we get the value of n equals to m plus 2 minus r minus 2. And when when x equals to 2, then r equals to 0, and when x equals to n, then r equals to n minus 2, then r equals to n minus 2. So we can write the term summation of r equals to 0 to n minus 2, 0 to n minus 2. Here n minus 2 factorial means m factorial, n minus 2 equals to m, so m factorial by the denominator's term r factorial, term will be r factorial into m minus r factorial, and p to the power x minus 2 equals to r into q to the power m minus r, q to the power, here we put this value, and finally we get m minus r plus np into n minus 1 p square summation of r equals to 0 to n minus 2. We have to convert this term into binomial form, so then we get m combination r, n combination r, p to the power r, q to the power m minus r plus np equals to n into n minus 1 p square. The whole term will become p plus q, because we know from binomial form the whole term will become p plus q to the power here m plus np, from noted here from binomial form. And then finally n into n minus 1 p square plus np. Here p plus q equals to 1 to the first something is mean 1. Now finally we will able to find expectation of x square's value. Now the value of expectation of x squares will be put it here, the variance formula. Then here the variance formula, variance of x equals to expectation of x square minus expectation of x whole square. Expectation of x square's value will be put here n into n minus 1 p square plus np, this minus here expectation of x, we get expectation of x value is np, and its whole square equals to, whole square means n square p square. Now here the term n square p square minus n p square plus np minus n square p square. The term n square p square and minus n square p square get cancel out. Here the remaining term will np 1 minus p, and finally we get the variance npq, 1 minus p equals to q, and finally we will able to find out the variance of binomial distribution. So if you benefited from this video, you may subscribe my channel Arif's math class. Thank you.